Okay, good afternoon, IB Biology. This is Mr. McGee here on this Friday. This week we worked on our lab report with yeast metabolism by temperature. You guys were to make a graph and process the data. And I told you you could do it on Google Sheets. This is my Google Sheets result. But then I noticed a problem after doing this and then telling you guys could do it on Google Sheets. Once again, Google Sheets has failed us. It is not letting us change the title to our legend of our series. Each series it will automatically label. It's not letting us have control over that. It's also not letting us process data in another way, and the reason I originally didn't want to use Google Sheets was because of error bars. Unfortunately, ladies and gentlemen, we are going to not be able to use Google Sheets with this. I strongly apologize. It is the software, and all I can say is you're going to have to do this on Excel eventually with your IA, so hopefully this is a good experience regardless. What we're going to be doing today is processing this data, and I'll just explain what we have first. We have an experiment right there. This is the time, if you remember, 0 through 300 seconds, and we had parts per million carbon dioxide concentration. However, this experiment is an experiment within another one. We are doing this at 25 degrees Celsius. We did it again at 35, 45, and this is all the different temperatures. So in a way, we actually have 5 different experiments, or we could say 5 different series. Therefore, we're not going to have one tread line. It's going to actually be 5 different tread lines. You'll notice I have 5 different groups data results here. We're going to use these as trials. I had a lot more groups than these, but just to give you a heads up, I actually narrowed these down into 5. Number one, just to give you less work that you have to do, but I also am just making it 5 because it's because many of the others, the data was all over the place. Not that I want to cherry pick, but I think it was user error rather than the result of science itself. So we don't want to get into the habit of cherry picking, but 5 is easier to work with anyways. So first thing we're going to do is tidy this up here a little bit. So let's go ahead and here click insert a line, or I'm sorry, insert a row, and let's give ourselves a little space to work over here like this. Let's go ahead and title this temperature. And we want to, now that we have a label, we want to have our unit in parentheses in there. So let's do in degrees Celsius. On a Windows computer, that's Alt 0176, and that's in degrees Celsius. Whoops, move my cursor back. Whoops, put my parenthesis in there. So you've got your label and you've got your unit, but we need to up it up a notch. We need to have our uncertainty. Do you all remember that when we did 25 degrees Celsius, the hot plate was not holding the temperature at a solid 25 degrees? Some of you, it was jumping up to 26, falling back down to 24. It was never held at exactly 25, but it was, I would say from my personal observations, it would not go much more above than 26 or down to 24 degrees. I would say, therefore, it's accurate to within plus or minus 1 degree. Same thing up here, plus or minus 1 degree at its worst. Therefore, we're going to put an uncertainty in here. To do this on a Windows, you hit Alt 0177. By the way, you can also come up here to Insert, and it should say symbol, and you can come over here to symbols and find all the symbols for plus or minus and all that in here as well. But if you learn the Alt keys, you don't have to worry about that. So I'm going to say plus or minus 1 degree, plus or minus 1 degree Celsius. Let's do this for time as well. This is our second independent variable because remember it's an experiment inside of an experiment. We'll do here time, and we'll put here in seconds, time in seconds. And the question is, do we need to have an uncertainty in this one? Because if I was using a stopwatch, this wouldn't necessarily be data at 0 and 60 seconds exactly. I mean, when you look at your stopwatch, it might be a second or 2 or even 5-second delay between when you see the time hit, you look at the probe, and then you write it down on the paper. So in that case, it's going to be plus or minus a second. But because we used a digital probe that recorded it exactly at those intervals, we don't need an uncertainty for this time. That can be held exactly. If it's something that doesn't need an uncertainty, you don't need it. Now the next one here is concentration of CO2. We're going to call this, centration. Sorry, I'm multitasking, you know me. Concentration of CO2, and just to make, concentration of CO2, and this is in parts per million. And Again, what would be our uncertainties for this? Well, in this case, I can look on the CO2 probe, and when I looked on the CO2 probe earlier, it said it was plus or minus about 50 degrees. Or, I'm sorry, 50 parts per million. However, in my experiment, whoops, let me just enter this in here real quick. Again, when I looked on the probe itself, it said plus or minus 50 parts per million. But in reality, I saw these numbers jump up more than this on many occasions. And that tells me that the probes are just in really bad shape. They're old and students have spilled stuff on it. Therefore, I'm going to say it's even worse than this. I'm going to go ahead and say 100 parts per million. And honestly, you can, as a scientist, say whatever you want to, as long as you are confident these numbers are accurate to within 100 parts per million, and these temperatures are accurate to within a degree Celsius. We know the time is exact, so it doesn't need an uncertainty. Okay, now that we've said that, we've got everything here set up, so now let's go ahead and add some brackets, but first, I'm going to show you a trick here to get these on a line. Let's go ahead and move this bar over here, and you notice it cuts off our uncertainty. So what I'm going to do is I'm going to do this. I'm going to go up here to Home and go Merge and Center, and now we just made it worse, but it did merge those cells. And now I'm going to go to Wrap Text. That puts it in a nice little column like that. Same thing with this. I'm going to highlight these two and say Merge and Center, and then I'll go up here and make it nice and centered in between there. And this one here, I want the concentration of CO2 to be highlighted over these groups, so I'm going to go over here and I need to merge all those cells, and then I'm just going to nice and neat center it. Okay, the groups don't need any merging, they should be good with that. Oops, I forgot one other thing. We forgot to add our mean and our standard deviation over there. So I guess that means I need to once again merge and center in these two cells as well. So now it covers it. And now that I have that, let's go ahead and add a box, a border to all of these cells here. And since these are our headings, let's go ahead and add a little background color to this. And because this is not our data, it's kind of a heading, I'm going to add a little color to those too. So now that we have that done, we can proceed to commence with the rest of this. Let's go ahead and calculate the mean. Remember, you can always click on a cell and go to f of x to calculate it, where you just find average. Or I can take the shortcut in Excel, which is just click all the raw data and highlight one cell over, and then you go over here to auto sum and hit average. We can't do that for standard deviation. We have to click the cell and go to f of x, and then of course you'd have to find stdev, and we're just going to have to manually go group 1 through group 5 on this. There is no other alternative, but at least you can click and copy and paste those cells. On Windows, remember, copy is Control-C, paste is Control-V. And the last thing we need to do is look at decimal points. The raw data is all rounded to a whole number, therefore the mean and standard deviation should be rounded to one more decimal place. Come up here to numbers, oops, and we don't want that many. Let's go ahead and round it to there. All right, and there is our data, and for all practical purposes, it looks like we're done. We should be able to make a graph right now. I mean, if you think about it, we have the time, which is our x-axis, and we have the mean of CO2, which is our y-axis. We could plot the graph just using this here. The only problem is, do you see these numbers for the first group here? This group starts at time 0, 1400. This one starts at 4000, and this is at almost 800. These numbers are all over the place. That's because these probes are not calibrated. Some of the probes have a different starting point, and therefore we need a baseline. We cannot use it like this. It would not be accurate to get a mean like this. After all, the mean is representing these. It just simply does us no good. Therefore, what we're going to do next is a little tedious, but it's going to be a lot more accurate with our result processing. What we're going to do is we're going to make a copy of this. Go down here to Sheets and click Move or Copy, Create a Copy. And I'm going to move this over here. This is Sheet 2. We're going to call this Baseline. And let's just go to Sheet 1 and rename that Raw. You don't have to do that, but just so you can see the difference. So I've made a copy, and we'll go back to this raw one here, and just so there's no distinction, I'll say raw data, concentration of CO2. And now I'm back on baseline. Let's go ahead and call this baseline concentration of carbon dioxide. That way we can see this one's our calculated and this one is just our raw unprocessed one. So this is a little tedious, but here's what we're going to do. For each group in here, we're going to calculate the baseline at its zero value. So to do this, you click on group 2, or really anywhere in here, right click, insert column. Do the same thing for group 3, right click, insert column, and do it over group 4, insert column, and last one for group 5 is insert column. And we, need to do it one more time. I'll do it over the mean because I need one for group 5 here, okay? So we should have 5 empty spaces, one next to each group, and this is where we're going to calculate our baseline values. Now this is a little tedious, so bear with me, but it's really not all that hard once you get the hang of it. Basically, we don't want these all starting at a different value. We want them all to be as if they were started at 0 at the 0 time of seconds. So how do we calculate this? Well, what we're going to do is take each cell in a given section and we're going to subtract it from the initial. To do this, I'm just going to set the initial one up here. I'm going to do the formula up here just so you can see it, but you just enter it right down there. So what you're going to do is hit equals, and the initial value for this group is 1424, and this is cell C3. So I'm going to say equals cell C3, and you see it highlighted the cell there, equals C3, and I'm going to go ahead and subtract that from the baseline, 1424. Okay, and when I hit hit enter, it should equal 0, and that's all there is to it. Now I'm going to go ahead, and I could do it for each cell here, might I add, but I'm not going to do that. I'm just going to Control-C copy it and Control-V paste it. And there is my values adjusted with a baseline of 0. Unfortunately, I can't go all the way down. I have to do it again for this one because it's a whole different experiment. I'm going to hit equals, and this is cell C9, and I'm going to subtract it from the baseline, which is 1374, and there we go. Now basically we could redo that for all those, but again I'm just going to go ahead and copy it like that, and there we go. Now basically you're going to do the entire thing for each one of these cells and do it in each one of these columns, and this is the part that can be a little tedious because when you enter, when you enter all these numbers, it takes a little while, but as long as your first one here enters as 0, you know you have done it correctly. So I'll do this last one here so you can see. This is cell C21, and I'm going to subtract it from 1057, and then we're going to do that for each one of those cells by basically just copying that equation. So I'm going to pause this video and go ahead and calculate all of these real quick just so that we have this ready, and I'll join you again here in a moment. Okay, thank you for bearing with me while I get all this calculated there. And again, notice that each value now starts at 0 and it goes up accordingly. So what we're going to do now is we really don't need these original groups here because that is provided in our raw table section. So we're going to go ahead and get rid of those, but watch what happens here real quick. Because I can click here, group 1, I don't need that column. Let's go ahead and hit delete column and watch what happens. It didn't work. That's because these values were directly calculated from that last cell, and without that cell existing, it doesn't know what its value should be. So I'm going to undelete that so you can see what happens. That means we have really no alternative. We need to move this to a different place. So in order to do this, it's again a little tedious, but we're just going to, and you got to bear with me, we're going to copy these values here, and then we're just going to move them off to the side in a special place. We'll go ahead and here and click paste a value. And now I got to do it for the second one. You got to do these one at a time. Unfortunately, you can't paste them as a row. And notice I'm pasting it as a value. Don't just paste it as an equation, otherwise you'll never see it again. It'll just appear as value. You have to paste these as values, and I'm right-clicking to do that. I'm copying it the same way with Control-C, but I'm pasting it as a value. Okay, and last one. Little tedious, but now we can make this work with something. And now that leads us with the last thing. We can go ahead and get rid of a bunch of these rows here. In fact, let's go ahead and get rid of these because we don't need them. Let's see how this works here. Should make it smaller. And these values here are really doing nothing for us. Let's go ahead and delete those. And I'll delete the titles. And now we just have to find a way and stick these in there appropriately. So basically what we've done is we took out the calculated values and we put them over here so we can use them. And now we've cleared an opening. Let's go ahead and paste the values here. And there we go. And I'm going to right click over these and delete these off. There we go. Now it looks like Excel has automatically updated everything for us, and the mean and standard deviation are already calculated. We don't have to do it again. So our data is much better now as a result. Everything starts off at zero time, and we can be more confident of our results and the mean and standard deviation that result from it. So just kind of something to keep in mind. That's why we want to use a baseline. Now, you are still going to have to copy your raw unprocessed data. In fact, let's call this raw unprocessed data. And we'll call that raw unprocessed because it doesn't have the baseline. This one here has the baseline, and let's go ahead and rename these group 1. Let's say here group 2, group 3, group 4, and this is group 5. Okay? So now that we have the groups all in there, everything looks good. I'm going to go ahead and save my work because it is an Excel file, and you don't want to lose it like you would on Google. Oh, that reminds me of one other thing I forgot to do. How silly of me. These temperatures here are corresponding to this entire row. We really need to get these temperatures merged. Let's go ahead and do that. To do this, we're just going to highlight the cells that correspond to 25 degrees. I could be annoying, by the way, and just enter 25 in all of these, but that's just really lame. We're not going to do that. To do this, we're going to highlight all these cells, and we're just going to merge them together like this and come up here and shift them up just like that. So I should have done that on the last page, but hey, when you're multitasking and making a video like this, it can be rather difficult to do everything and get it as accurate as you need it to. In fact, I have some notes in front of me, so I'm trying to remember to say everything. And then you got to go back here and do that with your raw. I'm just going to do that real quick. Okay, I've calculated, or I've merged and centered all of these for raw and baseline. It just looks a lot nicer. All right, so back to what I was saying. Now you got your two tables made up, the baseline and the raw. Now what we're going to do is we are going to make our graph, but we're only going to do it for this baseline. So to do this, it's just like any other graph. You've got your time and you've got your mean. So, I apologize, my phone just rang. I had to pause this real quick. So you've got your time, which is your x-axis, and your mean, which is your y-axis. We could just make the graph like this, but keep in mind we've got several different experiments. That means we've got to combine these. Let's go up here to insert, and let's go ahead and enter scatter plot. Now normally you'd want a trend line that does not connect through the dots, but in this case we don't really know where the values lie between these dots, so we're just going to go ahead and we'll just add the straight trend line here in this case. In this lab it's a little easier to do that, so I'm going to move this to this. Well, hopefully you can all see this from where you're sitting. Let's go up here and select our data, and we're going to add each experiment one bit at a time. Series name, let's call this 25, and let's see if I can enter the degree symbol there. Whoops. It let me. Good. 25 degrees Celsius, and select our X value. That's going to be time, of course. Select our Y value. That is going to be the mean parts per million concentration, and there we go. Next one, we're going to add the next one, and this is for, of course, 35 degrees Celsius. Alt 176 is it on a Windows computer. I'm not really picky or not if you add the degrees symbol, but it does look very nice, and after all, you're doing this much work, you might as well put a little bit more into it. Next one here, we're going to call this 45. I'm going to, enter 0176, select the range. I am going to just pause this real quick while I do the next, but at least you've seen how I've done this, and you can see these are getting entered. Okay, I unpaused the video so I had time to enter these in. I didn't have to make the video longer. You'll notice I have all my series, which are really all these different experiments. For most of our labs, we've just done one experiment and you only had one series. And that's why you haven't seen me enter multiple series like that. There's our graph. Now we just got to do what we've done on pretty much all the other videos. We want it to be scaled appropriately. And like I said, I like to get rid of the grid lines. I just click on them, or you can come up here and just unclick grid lines. But we definitely need to have access titles here. As far as a chart title goes, you may put a chart title in here, or you may write this underneath on your lab report, but don't forget the chart title on your IA, okay? And so we have access titles, and we also we don't need data labels. And I told you we don't need error bars for this, but we probably should have legend. Make sure you click legend. I don't believe in any lab up until this point I've made you guys do this. Okay, now that we've got legend selected, we just need to title our axes. And guess what? They are exactly the same as over here. This is going to be time, and this is in seconds. And over here, this is going to be baseline, concentration of carbon dioxide, and don't forget your uncertainty and your unit, plus or minus 100 parts per million. Always should be the same, or at least in most cases. If your graph is looking really small like this and it's not looking like it's readable, you can do this a little bit smaller so when you copy and paste it, it pastes better. But make it look a little nicer like this. Don't make your graph look like this, because some of you have been turning in lab reports, no joke, that have looked like this. And some of you have turned in lab reports that look like this. You want your graph to very nice and neatly fit an image screen like this and tell a story that you're trying to tell. So I think this is a good size. I can read the numbers at this size, and I am going to, however, click on the time, and I'm going to blow it up just a tad bit here, and maybe add it bold. And I'm going to do the same thing with this one, blow it up maybe just a tad bit, and click and maybe move it over. So now we just want to tidy a couple other things up. I don't need a decimal place over here, so let me right-click or double-click on that. And let's go down here to number, and let's just say no decimal place. That should eliminate that. And now I'm going to ask myself, do I like these units? Do I want them going all the way up like this? I'd say yes. It looks like it doesn't have a lot of extra space up here, especially with my chart title there. Now, normally I would say don't make your graph go to 350, but in this case, having the legend to the side means this is okay. But you may also do it this way if you so wish. You may stick this over to the side, and you may double click on, whoops, close it out. You may double click on this and then just end it at 300 seconds as well. So that is completely up to you guys if you wish to do that. I will leave that up to you to decide, but nevertheless, notice everything is, well, it fills up the screen very nicely. It's legible, I can read it. You don't have an axis where it's super small font like some of you have turned in. Make sure it's nice and readable. You can change the font size if you have to. Likewise, change the font size of this if you have to. It's up to you guys to do that. And everything else looks good here. You may put your chart title. What exactly is this representing? And with that said, here's the last thing you guys need to do. You guys are going to copy the table and copy the graph. You guys are going to paste these into Google Classroom's Word file that I'm providing you. And then you guys follow the instructions as provided, as we've done a lot of times prior to this. Like I said, it is annoying, I apologize, but you are going to probably have to go to Windows and type in snipping tool, or on MacBooks they have something different, and you are probably going to have to use this to snip out the image. It's only because we're using a Windows computer to do this, at least in my example. But when you guys write your IAs, you won't be doing that because you'll be using Word, and it pastes a lot easier. The other thing you could do, you can always just hit, I believe on my computer it's FN, and then hit the key print screen on my keyboard, and it'll print your whole screen if you come to a paint file, and then you just paste the whole screen. So here's another alternative you can do if you don't have the snipping tool, and I know for sure MacBooks have this. But, you know, like everything else, ladies and gentlemen, I had to learn all this by Googling it. If you can't figure it out, just Google, where is the snipping tool, or how do I snip something off of Microsoft or a MacBook? I'll let you guys figure it out. You're practically adults, and be the scientist. Figure it out how to do that if you can't copy and paste it on your computer. Another announcement I might share with you, there is another data processing tool called LibreOffice. I found it does process a lot similar like Microsoft Excel. It is free to use. You may download that as well if you find that Excel is not something you have easy access to and you wish to do this at home. Other than that, that is pretty much it, ladies and gentlemen. Remember, you are copying your table from raw and baseline and your graph of your baseline data as well. And then you guys are responding to the questions that is on the Word file, okay? With that said, I wish you luck. Please don't wait till the last minute, and I will make sure that we do things accordingly. Thank you very much.